In section 3.3, we'll talk about a division of a polynomials, okay? And we will use this division to find the factor of the polynomial function. Okay, before we go to the definition, just let me take a simple example. So if we are dividing, let's say we are dividing 54 by 3, okay? Now we can use a long division. You all have seen long division. So we divide 54 by 3. And how do we divide this? Or like, okay, let me take a small number here. Okay, instead of 54, let me take 20. Okay, now how do we divide this 20 by 3? Yeah, so 3 times 6, that is 18, right? Then we find the difference between 20 and 18, which is 2. Now here, what do we call this 6 and what do we call this 2? What are their name? What is this 2? What do we call this? This 2 is the remainder, okay? What do we call this 6? We call quotient, okay? What do we call this 3? What do we call this 3? So divisor, the divisor. And what do we call this 20? Dividend, yes. Okay. Now here, in this section, we don't divide the numbers. We have the polynomial function, okay, or we have the polynomial expression. So we divide a polynomial by another polynomial, okay, and we try to get the quotient and the divisor and the remainder. Okay, now one more example. So if we are dividing 10 by 2, so our quotient is 5, so 5 times 2 is 10. We have 0, so our 0 is the remainder, right? So we have the 0 remainder, 5 is the quotient, 2 is the divisor, 10 is the dividend. Now if our remainder is 0, what are these 2 and 5 for 10? So if our remainder is 0, see, we get the remainder 0 when we divide 10 by 2. And when we get the remainder 0, what are these 2 and 5 for this 10? 2 and 5 are the factors for 10, right? So if we get the remainder equals to 0, then our divisor and the quotient, they are the factor. Okay, so we will use this division method to find the factor of the polynomial. Now in general, okay, so we have our p of x polynomial function, okay. This p of x is divided by d of x. So this is our dividend, okay. And we have a d of x. This is our divisor. And when we divide p of x by the divisor dx, okay, we can always rewrite our polynomial function p of x as a divisor times quotient plus remainder. Now here, what I mean here in this example, so here our 20 is the dividend, right? We can write 20 is equals to divisor times quotient. So divisor is 3 times quotient is 6 plus remainder 2. Is it true or false? See, we have our divisor, okay. Our divisor is 20. So our dividend is 20. So we can always rewrite dividend 20 equals to 3. 3 is the divisor times quotient plus remainder. So 3 times 6 is 18 plus 2 is 20. So we can always rewrite our dividend is equals to divisor time quotient plus remainder. In the similar way, we can write this 10 is the dividend. We can rewrite 10 equals to divisor, which is 2 times quotient is 5 plus our remainder is 0. Okay, that's what it means here. So we can always rewrite our dividend, this is the dividend, equals to divisor times quotient plus remainder. Okay, and if you divide both sides of this equation by d of x, this is what we get here. Okay, and the next thing is that the degree of remainder is always less than the degree of divisor. Okay, so when we have the polynomial, the degree of the remainder has to be always less than the divisor. Okay, and the next thing is that if the remainder is 0, our divisor and the quotient, they are the factor of the dividend. Okay, if we get the remainder equals to 0, the divisor and the quotient, they are the factor of p of x. Now we have an example here. Now we have to find the quotient, right? So we have to find the quotient. Our quotient, we have been using q of x, so we need to find quotient q of x. We need to find the remainder, so we are using r of x. Okay, remainder, when 2x to the power 4 plus 7x cubed plus 4x squared minus 7x minus 6 is divided by 2x plus 3. Now what is this expression? So is this now divisor, dividend, quotient, or remainder? So we are dividing this polynomial by 2x plus 3, right? So our 2x plus 3 is the divisor. So we have a d of x, and this expression which we are dividing by our divisor is our polynomial p of x. Okay, our target is finding the remainder and quotient, and here we will use long division. Okay, so we will use a long division. So we will have two different methods. So we will use long division method, and in this method we write down our divisor. So our divisor is 2x plus 3, so we write down our divisor 2x plus 3. Okay, and we are dividing our polynomial function, which is 2x to the power 4 plus 7x cubed plus 4x squared minus 7x minus 6. Okay, so you can write quotient here. Okay, and the remainder, that's what we need to find. Now how do we find the quotient? Have you done long division before? Okay, now here the very first thing that you need to check is that your polynomial function or your polynomial and divisor, you have to write your polynomial and the divisor in the descending order of exponent of the variable. Now let's double check. Do we have our divisor? So our divisor is 2x plus 3. Now do we have our divisor in the descending order of exponent of the variable? Okay, so the exponent of this variable is 1, so we don't have variable, that is 0. So 1 0 is the descending order. Similarly our polynomial, so we have 4, we have 3, we have 2, we have 1, we have 0. So this is in the descending order. So every time make sure your polynomial and divisor is in the descending order of exponent of the variable. Okay, that's the first thing. Now the next here is that we take the leading coefficient. Okay, we'll take the leading term of the dividend and the leading term of the divisor. Now this is our dividend. Which one is the leading term? Which one is the leading term for this dividend? Leading term is the term with the highest degree. Okay, now this term has a degree 4. Okay, so this first term is a term with the highest degree 4. So this is our leading term. We are not taking the coefficient. Okay, we are taking the leading term. It means we're gonna take all. So here we will divide this leading term of the dividend by the leading term of the divisor. So the very first step, we are dividing the leading term of the dividend. Okay, so this is the leading term of the dividend by the leading term of the divisor. Now what is 2x to the power 4 divided by 2x. So what is 2x to the power 4 divided by 2x? This is, so 2 cancel, right? X to the power 4 divided by x is x cube. And this x cube is the first term of our quotient. So we write here x cube. So you take the first term, okay, or you take the leading term. So you take the leading term of the dividend. Okay, so this is our leading term. And you divide this leading term by the leading term of the divisor. Okay, and whatever you get is your first term of the quotient. Okay, that's the first thing. Now, once you find the quotient, first term of the quotient, now we multiply this first term x cube and every term of the divisor. Okay, now we multiply x cube. Okay, we multiply this first term of the quotient, okay, with every term, not only the first, every term of the divisor. Okay, and we write down in the second row. So x cube times 2x is 2x to the power 4. You are dividing every term. X cube times 3, positive 3 is positive 3x cube. Okay, once you have the quotient, once you have the first term of the quotient, you use that first term of the quotient to multiply every term of the divisor. Every term, you have to multiply every term and write in the second row. That's the next step. Okay, now we subtract our first row and second row. For that, we change sign of each term in the second row. So what is the sign of this first term? It's positive, right? So we change into negative. Okay, and the sign of this 3x cube is positive, so we change into negative. So if you have positive, you change to negative. If you have negative, you change to positive. Okay, now we will be using this new sign. Okay, now this negative is the sign for this 2x to the power 4. This negative is the sign for 3x cube. So we're gonna use new sign. So we have 2x to the power 4 negative 2x to the power 4. This cancel, right? So this is 0. We have 7x cube negative 3x cube, and this is equals to 4x cube. Okay, now we drop the remaining terms. So let's drop the remaining terms. So we have positive 4x squared negative 7x negative 6. Now we repeat the same process. Here we take the first term, we take the leading term. Okay, this is the leading term now. We divide this leading term by the leading term of the divisor. So we divide 4x cube by 2x. So 4x cube divided by 2x is 2 times 2 is 4, right? 2x cube divided by x is x squared. And this is your another term for quotient, and that's what you're going to write here. So we have positive 2x squared. So you take the first term of the this is your new dividend, so first term or the leading term, and you divide this leading term by the leading term of the divisor. 4x cube divided by 2x is 2x cube, positive 2x cube, and that's what you write in the quotient. Okay, now you use this term, only this term, to multiply every term of the divisor. Now we use 2x squared to multiply every term of the divisor. 2x squared times 2x is 4x cube. 2x squared times positive 3 is positive 6x squared. Now you change sign. So 4x cube is positive, so we change into negative. 6x squared is positive, we change into negative. Okay, now we simplify. So positive 4x cube, negative 4x cube. You're gonna use a new sign. So this is 0. 4x squared, negative 6x squared. And this is negative 2x squared Now you drop the remaining terms. So negative 7x, negative 6. We repeat the same process. Okay, you take the leading term. So negative 2x square is the leading term, and we divide this leading term by the leading term of the divisor. So negative 2x square divided by 2x, this is negative x, and this is your another term for the quotient. That's what you're going to write here, negative x. Now we multiply this negative x and every term of the divisor. So we multiply negative x and 2x. So negative x times 2x is negative 2x square. Negative x times positive 3 is negative 3x. Now you change sign of each term. So this negative 2x square change into positive 2x square. Negative 3x change into positive 3x. So negative 2x square and positive 2x square, this is 0. Negative 7x, positive 3x, you are using the new sign, okay, after changing. Negative 7x, positive 3x, that is negative 4x. Now we have this term left, we drop this, which is negative 6. Now again you take the leading term, so you take the negative 4x and divide by positive 2x. So negative 4x divided by 2x, this is negative 2, and negative 2 is your next term for the coefficient. Now you use this negative 2 to multiply every term of the divisor. So negative 2, so negative 2 times positive 2x, negative 4x. Negative 2 times positive 3 is negative 6. We change sign. So negative 4x change into positive 4x. Negative 6 change into positive 6. So negative 4x, positive 4x, 0. Negative 6, positive 6, 0. So we have 0 here. Okay. Now what is this 0? This is our remainder, right? Which is r of x, remainder. And what is this? This is our quotient, and we use q of x. So this is our q of x. Here the remainder is a 0. Now when the remainder is a 0, what can we say about this divisor? So this is the divisor. So what can we say about the divisor and the quotient for this polynomial? These two are the factor, okay? So every time if you get the remainder 0, then the quotient and the divisor is always a factor for the given polynomial. Okay, let's do one more. Do you have any question here? Now let's use a similar method, long division, okay, for example 2. But for example 2 we have to use the synthetic division, but before that let's use the long division, okay. So this is, so our divisor is x plus 2 and our dividend is 6x cube positive x minus 1. So our divisor, this is our divisor and this is our dividend. We need to find the quotient and the remainder using our long division. First step. Now what do we check? We check whether our divisor and a dividend is in a descending order of exponent of a variable or not. That's the first step, okay. So divisor and dividend, they both are in the descending order of the exponent of the variable, okay. Next what we do, we take the leading term, okay. This is our leading term for the dividend, and we divide this leading term by the leading term of the divisor, okay. When you find the quotient, you take the leading term, okay, you take the leading term of the dividend and you divide this leading term by the leading term of the divisor. So 6x cubed divided by x, 6x cubed divided by x, this is 6x square, and this 6x square is the first term of the quotient, so that's what we write here, 6x square. Okay, next we multiply this quotient and every term of the divisor. Okay, we multiply this quotient and every term, okay, of the divisor. 6x squared times x is 6x cubed. 6x squared times positive 2 is positive 2x squared. Now next we change sign. So positive 6x cubed change into negative 6x cubed. Positive 2x squared change into negative 2x squared. Oh yeah, thank you. 6x squared times positive 2, yes, is positive 12x squared. Okay. The next we change sign. Now 6x cubed negative, we take the new sign, negative 6x cubed, this is 0. Okay. Now what about this? Positive x, negative 12x squared. Are these like terms? No, right? So we can't subtract. So we write negative 12x squared as it is. Okay. There's nothing to simplify. And we drop the remaining terms. So we have positive x, so we drop positive x and we drop negative 1. So we have positive x and negative 1. You drop the remaining terms. Now we follow the same method. You divide this first term, negative 12x squared, by the first term of the divisor. So negative 12x squared divided by x, this is negative 12x. And this is our quotient, another term for the quotient. So we have negative 12x. The next step, we multiply this quotient term and every term of the divisor. Okay, so negative 12x times x is negative 12x squared. Negative 12x times positive 2 is negative 24x. We change sign. So negative 12x squared change into positive, negative 24x change into positive. So this is 0. Okay, so we have positive x plus 24x, that is 25x. We have negative 1, so let's drop negative 1. One more time. So you divide the first term or the leading term 25x by the first term to get the quotient. So 25x divided by x, 25x divided by x, so we have 25, positive 25. So this is our quotient. Now you multiply positive 25 and every term of the divisor. So 25 times x, that is 25x. 25 times positive 2, that is positive 50. We change sign. So 25x positive, so you change into negative. 50 is positive, so you change into negative. This is 0. Negative 1, negative 50 is negative 51. And what is this negative 51? Our remainder r of x. And what is this? This is our q of x. This is our quotient. Okay, this is our divisor d of x, and this is your polynomial p of x. Now here is our divisor and quotient of factor for this polynomial. No, because the remainder is not equals to 0. Okay, now let's compare the degree of divisor, quotient and the remainder. So what is the degree of this dividend? Can you tell me the degree of this dividend? 3. What is the degree of quotient? 2. Okay, see, the degree of quotient is always less by 1 than the degree of dividend. Okay, so if the degree of dividend is 3, the quotient must have a degree 2. Okay, and so what is the degree of the divisor here? What is the degree of this divisor? 1. What is the degree of this negative 51 or the degree of this remainder? 0. So it means the remainder has always a degree 1 less than the degree of divisor. Okay, and it's true for every. So here, so this divisor has a degree 1, the remainder has a degree 0. Okay, similarly this dividend has a degree 4 and the quotient has a degree 3. Okay, the quotient always has a degree less by 1 than the degree of dividend, and the remainder has a degree 1 less than the degree of divisor. And this is long division method. So in your exam, if you are asked to use long division, then you have to use long division. Okay, any question with the long division? Okay, the next method here we have synthetic division. Okay, and this synthetic division, so you can use long division for any kind of division, but for synthetic division there is a criteria. We can't use synthetic division for every. Okay, so if the divisor is of form is a x minus a form, is x minus a is any number, a form, then only use synthetic division. Okay, so here, so this is the divisor. What is the degree of this divisor? 1. So if the degree of the divisor is 1, then only we can use the synthetic division. Okay, a is any number. Okay, so you must have before you use the synthetic division, you must check what kind of divisor you have. If the divisor has a degree 1, then you use synthetic division. Okay, if the divisor is not a x minus a form, then we can't use synthetic division. Like for example, so here okay, we can use synthetic division. So let me go to some different example here. Okay, so let me make an example. For example, if we have a divisor, let's say our divisor is x squared plus 1 and we are dividing x cubed plus 1. Now here, so this is our divisor, right? Now what is the degree of this divisor? 2. Now if the degree of divisor is 2, then we can't use synthetic division. We have to use the long division here. Okay, we use synthetic division only when your divisor is of this form, x minus a form. Your divisor has to be of this form, x minus a form. Okay, if the divisor looks similar to x minus a form, then only we use synthetic division. Okay, now in order to use synthetic division, we have to find, okay, in your book they have used a c, so let me use c here instead of a. Okay, so it's the same thing. So c, a, these are any number. So in order to use synthetic division, we need to find what is c at first. Now for this example, which one is divisor? Can you tell me which one is divisor for this example? X plus 2, right? So we are dividing 6x cubed plus x minus 1 by x plus 2. So this 6x cubed plus x minus 1, this is our polynomial, right? P of x, and this is our divisor d of x. Now the very first step is that we compare our divisor with this x minus c and find what is c equals to. So our divisor is x plus 2. Okay, we compare with x minus c. Now if we make a comparison, what do we get for c? So what should be c so that we get x plus 2 from x minus c? What should be c? C has to be negative 2, right? So c is negative 2. Now if you compare here, so for x we have x. Okay, now we can rewrite this here. So x plus 2 is same as x negative negative 2. Okay, so for x we have x, for negative we have negative, for c we have negative 2, and that is why our c is negative 2. Okay, that's the very first step. You find what is c. Okay, and in order to find c, you compare your divisor by x minus c. Okay, if you have a positive, it will be negative. If you have a negative, it will be positive. Okay. Now the next here, we write down the coefficient of each term of this dividend. So this is the dividend. So we write down the coefficient of each term. Okay, only the coefficient of each term of the dividend. Okay. Now what is the coefficient of x cube terms? 6. Okay. Now in the descending order, after x cube terms, we get the x square term. Now, do we have x square term? No. And if you have any missing term, you're going to use 0 as the coefficient. Okay. After a square term, we get our x term, and the coefficient of x term is 1. Okay. And at the end, we have a constant -1. So, we write down the coefficient of each term. And if there is any missing term, we use 0. Okay. So we use 0 for any missing term. And make sure you always need to have your polynomial in the descending order of exponent of the variable. Okay. Before you write down the coefficient, make sure you have your polynomial in the descending order of the exponent of the variable. That's what we already have here. Okay. And the next, you write down the coefficient of each term. If there is a missing term, you're gonna use a 0 as a coefficient. Okay. Now we divide this coefficient by our c. So we divide this coefficient by our c, which is -2. Okay. Now we are dividing the coefficient of each term by -2. And if there is missing term, make sure you're gonna use a 0 for that missing term. Okay. Now the method is here, so we drop the first coefficient. It doesn't matter whatever you have. So we drop first coefficient 6 as it is. Okay, you drop the first coefficient. Now we multiply this 6 with our c, which is -2. 6 times -2, that is -12, and write below the next coefficient here. Okay, 6 times. So you multiply. So you drop the first coefficient. You multiply this first dropped coefficient with this c, which is -2, and write down below the next coefficient. So 6 times -2, -12. Okay. Now we do not change sign here. So when we are using synthetic division, we do not change sign. So 0 minus 2, what is that? Sorry, 0 minus 12 is -12. Okay, we are not changing sign when we are using synthetic division. We only use for the long division. Now we repeat the same process. So we multiply this -12 and this 2 and write below next coefficient. So -12 times -2, that is +24, and you write down below next coefficient. We do not change sign. Okay, so 1 is positive, 24 is positive. 1 plus 24 is 25. We repeat the same. So you multiply this 25 and this c, -2. 25 times -2 is -50. Okay, and write below the next coefficient. We do not change sign. 1 is negative, 50 is negative, and this is -51. Okay, now here whatever you have at the end, so this is what we have at the end. This is always your remainder, r of x. Okay, so whatever number you get at the end, we have -51, and -51 is the remainder r of x. Okay, and this number are the coefficient of our quotient. Okay, so our quotient is q of x. Okay, and these 6, -12 and 25 are the coefficient of the quotient. Now before you write the quotient, we need to know what is the degree of our dividend. What is the degree of dividend here? So our dividend is this. Our dividend is 6x cubed plus x minus 1, and the degree is 3. So if the degree of dividend is 3, what can you say about the degree of quotient? it has to be less by 1, right? The degree has to be 2. So if degree is 2, what should be the first term of the quotient? It has to be x square, right? So our first term. So this is the coefficient of square term, okay? And this is in the descending order. This is our x and this is our constant. So we have 6x square, negative 12x and positive 25, which is the constant here. So this 6, 12, negative 12 and 25, these are the coefficient, okay? So you need to know the degree of quotient, and once you know the degree of quotient, you can write the term, okay, the variable with the exponent. Since 2 is the degree of quotient, so that's why we write x square, okay? And this negative 12 will be the coefficient for the term x, because in the descending order we have x cube, x square, x and a constant, right? So we have x and the last is constant. See, if we compare with a long division, we had the same answer, right? So our remainder is negative 51 and our quotient is 6x square, negative 12x plus 25. Okay, now let me do one more example and let me go back to the very first example and use, okay, so here we don't cover, so we always, okay, now our divisor is this one. Let me change the divisor. Okay, let's do one more example for synthetic division, okay? Okay, so here, so our polynomial is p of x is negative, so let me add one more. So our p of x is negative 2x to the power 4, x to the power 4 plus 6x cube plus 3x minus 1, and we are dividing by x minus 2. Okay, so this is the next question here. Now here, the very first question, can we use synthetic division for this case? That's the very first question we have to ask. You can't use synthetic division for every problem, okay? There is one condition. The divisor has to be of x minus c form. So this is our divisor, and if your divisor is of x minus some number form, then only we can use synthetic division, okay? Now here, what can you say? Can we use synthetic division? Our x minus 2 and x minus c, they are in the same form, both has a degree 1, so we can use synthetic division. So let's find what is c. So in order to find c, we compare our divisor, x minus 2 is the divisor, with x minus c. And if we compare, what do we get for c? So if you compare, for x, we have x, for negative, we have negative, and for c, we have 2. So our c is 2. Okay? You check whether you can use synthetic division or not. Next, you find what is your c. Okay? The next step, we write down the coefficient of each term. And if there is any missing term, we use 0 as a coefficient. Okay? Now, our dividend, it is already in the descending order of exponent of the variable, right? So no need to rewrite this. So the coefficient of x to the power 4 is negative 2. The coefficient of x cube is 6. Now after x cube, in the descending order, we must have x square term. So x square term is missing. So we're going to have a 0. Okay, after x square term, we have a x term, and the coefficient of x term is 3. And after x term, we get the constant, which is negative 1. And these coefficients are divided by c, which is our 2. So we use our c to divide this coefficient. How do we make a division? You drop first coefficient, so negative 2. You do not multiply. You just drop, okay? Next, you multiply this dropped first coefficient with this c. So negative 2 times 2, negative 4, and write down below next coefficient. So we write down here, negative 4. we do not change sign. Okay, only when you are using long division you are changing sign, but with the synthetic division we are not changing sign. So 6 minus 6 is positive, okay, right? 4 is negative, so 6 minus 4 is positive 2. Now we multiply, repeat the same process, multiply this 2 with this c. 2 times 2 is 4, write down just below next coefficient. 0 plus 4 is 4. Okay, we multiply this 4 and this 2. 4 times 2 is 8, write down below next coefficient. 3 plus 8, 11. Okay, you multiply this number with 2. 11 times 2, that is 22, write down below next coefficient. Negative 1, positive 22, that is positive 21. And what is this R21? This 21 is remainder R of x. Okay, R21 is R of x. Now the next thing, we need to find Q of x. Before you find the Q of x, you need to know what is the degree. So what is the degree of dividend? Degree of 4, the highest degree is 4. 4 is the degree. Then the degree of quotient will be 3. So to have a degree 3, our first term has to be x cube, right? So this is for x cube. Okay, this is our coefficient for x square term, right, in the descending order. This is for the x term and this is the constant. So we have negative 2x cube, positive 2 is positive here, so positive 2x square. 4 is positive, so positive 4x. 11 is positive, so plus 11. And this is our quotient. Now, is our divisor and quotient a factor here? No, because the remainder is not 0. Okay. Now, let me give you an problem for you. Okay, and the remaining portion we'll do tomorrow. So I will give an example, and you're going to use both method to divide. Okay, and if you need any help, I'll help you. Okay, let me take from your homework. Okay, this is 17. Okay, 17 from your homework. So your p of x polynomial is 3x cube plus 2x minus 8, and your divisor d of x is x minus 4. So you divide p of x by d of x, okay, using long division as well as synthetic division.